Good morning, children. I am Sir Roy Physics. Now I am teaching for class 9, lecture 2. Lecture 2, chapter Motion and Force. Motion and Force. In my lecture 1, I have told you if the particle initial velocity u, final v, then and time t, then acceleration you have got a equal to change in velocity by time. So we have A equal to v minus u by t. Acceleration equal to v minus u by t. Now this dimension is L by t and dimension of t is t. So t to the power L, t to the power y, m to the power 0. So it is clear that dimension of A is L, t to the power minus 2, m to the power 0. That means acceleration, classical mechanics, acceleration does not depend on mass. Power is 0. Now question is, now we have v equal to u plus at. This equation number 1 for motion, chapter motion, this is the first equation. Let us square it on both sides. What will get? Both sides. You are getting v square equal to u square plus 2u at plus a square t square, or v square equal to u square, you take 2a common, ut plus half at square. With the help of average velocity, we know ut plus half at square equal to s. So we have proved. So it is proved v square equal to u square plus 2as. This equation number 3. And another equation already you have derived, s equal to, that is equation 2. These three equation is very important when we are dealing with the chapter force and motion. Force and motion, if we do this chapter force and motion, then it is very important for us. Now let us consider what is the distance at time t, that is s suffix t. We know s suffix t equal to ut plus half at square. Distance at t plus 1 second given by st plus 1 equal to ut plus 1 plus half a t plus 1 whole square. In some books, instead of a, small letter f can be used to represent acceleration. So if we subtract 2 from 1, sorry, 1 from 2, 1 from 2, we have STH, distance at each second. We have STH equal to ST plus 1 minus ST, or we have UT plus 1 plus half a T plus 1 minus UT plus half a T square. If you calculate all, then you are getting U plus half a 2T minus 1. This is very important equation for all of us. That equation number 4. Generally, in motion chapter, we are considering 5 equations. That is very important. Again, I am in short, I am writing all equations that will be used to solve various numericals linked with this chapter one by one. I am just removing all material from the board. Now, class 9 CBSE, class 9 force and motion. Already these 5 equations very important. V equal to U plus AT. Next, S equal to UT plus half AT square. V square equal to U square plus 2AS. And ST second motion, U plus half A 2T minus 1. Next, average velocity that is equal to total path by total time. These 5 equations are very important connecting this chapter force and motion. Let us remove. After that, I am considering some simple numericals. How these numericals. Problem 1. These are the basic equation to deal with the physics for NEET or any competitive exam. If your basic is not clear, then you can't use available data on to solve this problem. First, you go through the problem, what information you are getting from the problem, and how to reach your answer by different physical methods and your conception. Let us consider, suppose a particle with initial velocity, suppose 36 km per hour. Initial velocity u equal to 36 km per hour. After 5 seconds, velocity becomes 54 km per hour. Question is, what is the acceleration? And distance? Very simple. What is the acceleration? What is the distance? Now 36 km per hour equivalent to 10 meter per second. It will be convenient for you. 10 meter per second. How? Suppose 36 km means 36,000. Hour means 3600. Meter per second going to 10 meter per second. Clear? Similarly, that means always remember in your mind that 18 km per hour means 5 meter per second. Now it is 54, 18 into 3, so it will be 15 meter per second. So V is 15 meter per second. So what is the acceleration? Which formula you want to use? V is known, U is known. You go to the first equation, T is known. From the first equation, V is known, U is known, T is known. Determine A. So A equal to V minus U by T. V equal to 15, U equal to 10 by 5. That is 1 meter per second square. That means you have got the acceleration. Okay. Now we are going to determine with the help of the equation 2. With the help of the equation 2, easily you can tell what is the displacement or distance if the body moving in a straight line. Distance equal to U is given, that is 10, T is given 5, half A 1, already I have got 5 square, that is meter in unit. So 50, 12.5, it is coming 62.5 meter. The displacement of the body in 5 seconds will be 62.5 meter per meter. That means first, to solve any numericals in the long run, every day you go through the formula, and first you go through the numericals and see what information or data given to you. After that, you think with the conception or available formula how to reach your destination, that means your target. Suppose if you read through the problem, again I am telling, U is given, that is 10, V is given, that is 15, time is given, that is 5. Now you ask yourself that what formula should be fitted with the available data. You see the first formula, that is equal to V equal to U plus AT, that is V is given, U is given, T is given. So A you can obtain easily. After that, another problem I am solving you. Let us try. Under gravity, if we consider motion under gravity, very simple, motion under gravity. Suppose a body moving from height h, from rest. Consider what will be the final velocity. A body falling from height h and falling from height h with U equal to 0, that means body falling from rest. And let us consider question 1. Calculate time of fall. Number 2, what is the final velocity? Clear? Children, now data given, what is given? Given, you see, given H is given, U is given, G is given, you have to calculate V. Okay. Now you may ask me, when a body falling under gravity, acceleration should be taken as 10 meter per second square for your convenience. Generally it is taken 9.8, nothing is given, 10 you consider. So it will be 10 u0 h. So which formula must use? H is given u v, that means use this formula v square equal to u square 2gs, not as. When body moving under gravity, consider acceleration g, that is constant. This g is variable for different planets. G depends on mass of the planet and radius of the planet. In class 11 when we promoted, then we understand that g is not constant. V square equal to u square plus 2gs. Now what is v? That is equal to u0, 0 square. Suppose it is g, s, instead of s you consider h. So v is coming out 2gh. This is very important formula. When a body falling on the ground, then it will strike the ground with velocity 2gh. Next, so again I am repeating this problem. Suppose motion under gravity. When a body falling under gravity from rest, rest means u equal to 0. Now using this formula it is clear that what is the v, that u instead of u put 0, 2gs, v equal to 2gs. If g is given 9.8 you put, if it is not given you consider it is 10. Now after that, what is the time of fall? Time of fall means you are considering s equal to ut plus half gt square, because this equation used, because time is in second equation. So consider u0, so instead of s it is h, 0t plus half g t square. So t is coming out root over 2h by g. This equation number 3. What we have calculated? We have calculated the time of fall. We have calculated what is the final velocity. The v is the final velocity, t is the time of fall. So another equation, when a body falling from height h with initial velocity u, it is striking the ground with velocity v equal to root over 2h. Remember it. Next, t equal to 2h by g. More h, more time it will take to reach the ground. After that, another simple numericals I should consider for your convenience. Suppose problem is given from class 9. I shall try my level best to make you strong in numericals so that you can cover NEET, other competitive exams. At least you love your subject physics in a very interesting way. You take it as a challenge subject. You don't take it seriously. You think and it is a subject of game based way you think on the subject. Now I am considering, suppose an athlete completes half track of radius r quotient in time t. What is given? Athlete is running half of the track. Athlete is covering in time t. Track radius r. Question is this. What is the displacement? Question 2 is distance. Question 3, if he completes full track, what is the displacement and distance? Displacement and distance. Question is clear? Let us draw the picture. First case, case 1. Second case, case 2. Case 1. Actually starts from A, completes journey at B, completing half of the track. Then what is the displacement? Already I have told you. When you consider displacement, initial starting point A, final finishing point B, shortest distance in a particular direction, that is AB. So we should write displacement equal to, that is diameter of the semicircle 2r. Displacement 2r. Displacement is 2r. Clear? Again I am telling, covering half of the circle, starting point A, finishing point B. So total shortest distance, that is AB, that is the diameter of the semi-track. Question is, what is the distance? What is the distance? What is the distance? Semi-track. That is the displacement. AB is the displacement. AB is the displacement. And AEB, total path covered by the body, AEB, path covered, that is equal to AEB, that is equal to pi r. If r is given, you can obtain. So velocity, suppose you take the draw tangent, velocity downward, change in velocity downward. Velocity is given, displacement by time, so it will be 2r by t, but speed equal to path by time, that is equal to pi r by t. Is it clear? If it is complete the circle, if it completes the circle, then displacement starting point and finishing point the same point. So shortest distance is 0. So displacement is 0. For full track. For full track, when it covers full track, displacement is 0. But you always remember that distance is not equal to 0. Distance not equal to 0, that is equal to 2 pi r, that is equal to path delta L 2 pi r. That means A going to A again, full track, displacement 0 for full track, but distance not equal to 0, that is distance equal to 2 pi r. So children, what we have done today, in brief I am telling you, first I have derived all 5 equations. I have defined what is displacement, what is distance, what is average velocity, what is retardation, what is acceleration. I have told you why time unit come twice at the unit of retardation or acceleration. After that I use the basic concept in numericals so that you can easily apply your equation in numeric to calculate the numerical values. Next lecture 3 I am going to consider, next lecture 3 will be my Saturday physics from Saturday physics. My lecture 3 will be on. Lecture 3 will be on graphical motion, graphical representation of motion. So you wait for my next video where I shall try my level best to make it easy for you. What is the graphical representation of motion? Graphical representation of motion. Graphical representation of motion. Next video. If you tell your comment, at the same time you suggest what you are expecting from me for your benefit. Thank you all.